idea is rotational symmetry. So rotational symmetry, I'm just going to draw a random object here. Thanks. Okay, rotational symmetry is if you turn the object. So you'd have to turn the object like a doorknob. Turning it like a doorknob, rotating. Okay, so rotational symmetry is turning it to be the same. The center of rotation would be the pivot point. So on this object, there's my center of rotation. Order of rotations. How many times, how many turns you could do for it to be the same within a one circle rotation. So how many turns could I do on this object where it would land in the same position and look the exact same? 4. So the answer to this question is 4. On different objects, yes, but not on this one. So if I turned it to this position, that's 1 turn. You see it? I could turn it 2 positions, 3 positions, and then if I turned it 4 times, it's back to the starting. Yeah. Yeah. Angle of rotation, how many degrees do you have to turn it to be at the same look? So here's my start. If I wanted to turn it there, it would look the same. How many degrees is that? 90 degrees. Okay? If you turned it 90 degrees, it would look the exact same. Okay, I'm going to give you a little bit of a tidbit. Here's how you always do it. How many degrees are in this whole thing? 360. And you divide it by the order. So we had 4. So 360 divided by 4? 90. Okay, do you also know this? Because I might do this on the test, wink wink. I might give you the direction clockwise or counterclockwise. Do you know what that looks like? Okay. Okay, if you had that shape, what would it look like to turn it 90 degrees clockwise?
Turn it to the right. That way.
Then it would look like that. This is clockwise. So what does counterclockwise mean?
Opposite.
Opposite. If you could give me the question now in a clockwise, how much did I pivot it? If you could tell me I pivoted this thing, how much counterclockwise?
270.
270. Okay, does that look right? You could either go 90 degrees clockwise. This is also the same turn that you would do if you went 270 counter. Okay, So, here's two shapes. This is the center, and you would start spinning it. Okay. What is the order of rotation? How many little tick mark spins could you do within a circle? 4.
What'd you say?
So, how many degrees would you spin it?
360.
No,
What?
90. 360 divided by 4. What is the fraction of a circle you would spin it? 1/4. Yep. You would spin it 1/4 of a circle. 1/4 of a circle each time. Okay, there's my center of rotation. How many spins would you do inside one full circle? 3.
120.
So 120 degrees is how much you would have to spin it to be looking the same. So what's the fraction of a circle that I would turn each time? 1/3. Okay, so these two questions. Okay, sorry, you probably won't be able to see this if I draw on top of the black. There's my center. How many orders would this shape have? 2. There's only 2 times. You'd have to spin it. How many degrees? To look the same, how much degrees would you have to spin it around? 180. What did you do? 360 divided by 2. So I would have to turn it a half of a circle to make sure it looks the same. And the last one of the day. So here's the center of it rotating. How many orders? How many? 5. Which ends up being how many degrees?
72.
72 degrees on a spin gets you to look the same. So each spin would be considered a fifth of a circle. Okay, so this is your homework. You're going to do your reflections of symmetry, vertical, horizontal, oblique, and rotational symmetry.